Hello, this is video 8 of Interim 3 for Math 8 at Mercer Middle School. This is the final video in the series showing each of the sections of the interim coming up, so if you're just getting into this video, you can also remember to watch the other 7. This standard says use an equation of a linear model to solve problems in the context of bivariate measurement data interpreting slope, and this should say y-intercept. So what that means is bivariate means that we have an x and a y value. So we have two different variables, and we are showing different data points. So for example, we might end up with a scatter plot that looks something like this. Not a function from the previous standard. Every x does not have a unique y, but we do have a relationship we can see here, some description we could write that would look like a linear relationship. So for example, I could draw a line that best fits all of the data points and shows almost like the average of all of the points. This would show that this was a positive, linear. I would define this as bordering on a weak relationship or association. So this would be a positive, linear, weak association between x and y. Here's x, here's y. So if we were to look at a if we were to look at a question that was not just general points like this, but actually had values, we could start making sense of what that meant. So we are biologists, and we are studying bat populations. We're asked to predict the number of bats that will be living in an abandoned mine. We need to make a prediction about 3 years from now. To start, you will find the number of bats that have been living in the mine during the last 7 years. So here is our table. We have year 0, year 1, 2, 3, 4, 5, 6, 7, and each of those years has a different number of bats. So let's say that this study was done by the biologists keeping a notebook, and once a year on the same day every year, let's say January 1st, they were to go out and count how many bats. And notice it says in the thousands, so that's actually 327,000. 327,000 bats. And then as the years go by, notice what's happening. The bat populations are going down. So by the time you get to 7 years, we're only at 197,000. So I can already tell this is a negative association. I know that because as x increases, y tends to decrease. Now I don't know that there's a linear relationship yet. We have to take a look here. Is there a constant rate of change for how much the bat population is changing over time, or is there not a constant rate of change? I can figure that out by graphing my data, like it says to do in A, drawing my line of fit, and then writing an equation. And then once we write an equation, we can make a prediction. That's what the question asked us to do. How many bats will there be 3 years from now? Notice we're going to define now as, let's say that we just took this sample at 7 years. So we have 8 years, then 9 years, then 10 years. It would be, what would the population be at 10 years? Well, I can already make a prediction that because the bat population is going down, 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 its population is going to be less than 197,000. But how much less? If I were to check here, this is going down by 21. This is going down by only 7. This is going down by 29. So it's not a constant rate of change. So I can't just subtract, let's say, 10 bats 1 year, another 10 bats, another 10 bats. I wouldn't be able to do that based on what I see here. So I got to make a scatter plot to figure out what's going on. So we have 0 year, at year 0, there were 327,000 bats. 310, 330, that's a span of 20. So 320 must be there. 325, a little bit higher. 327. Year 1, 306. There's 300, a little bit higher, is 306. Year 2 is 299, slightly lower than 200, or sorry, slightly lower than 300. Year 3 is 270. Year 4 is 250, there's 260, so 254. I'm estimating as best I can here. Year 5 is 232, slightly above 230. Year 6, 215, there's 220, halfway between 210 and 230, so 215 would be halfway between 210 and 220. 232 for year, 232, 215. Year 7 is 197. So 190, 200, 197. So this actually falls in a pretty straight line, and I'm going to check this point because this looks a little funky to me. Year 2, 300, yeah, so there wasn't much of a change between those 2 years. So I did that, I graphed the data. Draw your line of best fit. So it says line of best fit, meaning I can't draw a straight line through these points. I could try, look at this. Nope, I can't hit all the points. I can hit that one, but it doesn't hit all the rest. I could hit this one, oh, but it's too high for all those. I could, so I'm not really trying to hit all the points. I'm trying to say, how can I best describe all these points using one line? I think it's pretty good. Now, I just so happen to have a y-intercept here. You know, it's not always true that you're going to start at a certain spot on the y-axis. You know, maybe actually, see how this is, I mean, it kind of gets these points, but these look a little low compared to these. We've got these two slightly off. I actually might be able to take that line and move it up slightly, but that's pretty good fit. So I've drawn my line of best fit. It doesn't hit all the points, but it gets really close to all those points. I like to think of these as magnets, and this line is a metal rod. If these magnets were all pulling on that rod, where would it probably settle? And it's about here. Write an equation for the line that you drew. Well, this is a linear equation. I know that because it's a straight line, and it fits pretty well. So this is a negative linear association. And I'd say it's actually pretty strong. I say it's strong because these points are really, really close to the line. So I also say it is a strong negative linear association. So let's write an equation. Y equals mx plus, now I'm going to, instead of writing b, I actually have a pretty good idea of where this y value is. So let's look at this graph. 310, 320, 330, 328-ish. So I'll put 328 here. All right. Now I'm going to think about my slope. I'm thinking here because I got to figure out what 2 points I'm going to choose. Now I got a little lucky here. I do have this point that's pretty directly on the line and this point that's directly on the line. Sometimes you're going to have no points that hit exactly on that line, but we do have 2, but I'm not going to use those 2. The reason is I don't want you to get in the habit of always looking for 2 points. I want you to create 2 points. So I've got this point right here is on my line. Remember, I want a slope of this line, not the slope between 2 of my points. For example, if I chose this point and I chose this point, I would find the slope, but it wouldn't be the slope of that line. It would be the slope of this line. Those are not the same 2 lines, so this point and this point would not be good points to choose. They're not on my line, so I'm not going to use those. I'm going to pick a point that is on my line, even though it's not one of my data points, because I'm not describing my data points right now. I'm describing the line of fit that represents my data points. There's another one way over here. So I've got 2 points right now. Point 1 is at 1, 310. That means at year 1 there were approximately 310 bats, and that's true. There were approximately 310 bats. At year 12 there'd be approximately 110 bats. Now I need to find my slope. So to find slope, I need to find change in y, y2 minus y1, over change in x. So my change in y values, I started up here at 310 and I went down to 110. My change in x values, I'm over here at 12, or should I start here? Start here at year 1 and went forward to year 12. So 310 minus 110 is 200 minus 11. So right now that's not a unit rate. I'm going to actually calculate my unit rate. So let's divide by 11 to make that something over 1 year. I mean, I already know what this means. This means that I lost 200 bats every 11 years. But let's find our unit rate instead. So 200 divided by 11 equals 18.1, and a positive divided by a negative is a negative. So what this represents, I lost an average of 18.1 bats every year. You can't lose 0.1 of a bat or 1/10 of a bat, but it's approximately 18 bats were lost in a year. That can mean a lot of things. 18 bats died per year, 18 bats flew away from that area every year. Whatever happened to them, they are gone. So we lost y equals 18 bats lost per year, multiplied by how many years happened, but we started off with 328. So that is my equation that represents this line. Nice thing about that is now we can make a prediction like we wanted to do in the beginning. What happens after 3 years from now? So 3 years from now would be 10 years from the beginning. Now is, here's now, 7 years. So 1, 2, 3 years. Here is 3 years from now. You can see that I can use my graph for this. 10 years is approximately 142 bats. So 3 years from now would be 10 years and approximately 142 bats. 142,000, I'm sorry. Actually, that's a good point. This isn't take away 18 bats. That's take away 18,000 bats. So a more accurate equation here would be y equals negative 18,000 bats plus 328,000 to start. So keep track of this says bats in thousands. So down here, use the equation to predict the number of bats 3 years from now. Y equals minus 18,000 bats, 10 years from the beginning, which is 3 years from now, plus the 328,000 that we started with. So minus 180,000 bats from the beginning of 328 bats. And if you do that calculation, you get 180 as a negative number plus 328, which is a positive number, 148,000 bats. This is in the thousands. So our equation, whoops, thousands. Our equation gave us 148,000 bats at year 10. Our graph told us it would be about 142,000 bats. Notice those are very close values. The graph was an estimation of the number of bats using a picture, and the equation gave us an estimation of 148,000 bats using a more precise or more exact strategy of using our equation. So what does the y-intercept mean? If they were to ask us that, they do ask you that in other parts of your interim. The y-intercept represents 328,000 bats at the start of the study, and our slope represents, this is our slope, represents we lose 18,000 bats per year of the study. There you go. If you are needing more help with this standard, make sure you go to Khan Academy and search for 8th grade statistics and probability and look up bivariate data and look up also the part that talks about interpreting slope and y-intercept. Make sure you go to your teacher at lunch for extra help, use math enrichment time also, and create your toolkit.